Today, the entire globe is a potential theater of operations for the United States Army. For these officers, this is more than just a statement of fact. It is their working context, the basis of their mission. They are members of the Test and Evaluation Command of the Army Materiel Command. What are the effects of jungle heat, humidity, the other natural enemies of materiel found in the tropic environment? What can be done to minimize their destructive effects? The Test and Evaluation Command must answer such questions for every type of natural environment on Earth. In the frozen wastes of the far north, in the world's barren desert areas, as well as in the humid tropics, the Army constantly seeks answers to such questions as how can clothing, rations, field shelters, vehicles, radios, and weapons be made more resistant to the ravages of environment? How well are American soldiers equipped to live, move, communicate, and fight in the jungle? The Army's key center for getting these answers lies in the Panama Canal zone. This is Panama City, capital of the Republic of Panama. Modern, clean, and healthful. It is a place rich in history. Here stands the old city, destroyed in 1671 by Sir Henry Morgan in his ruthless search for Spanish gold. Majestic cathedrals, reminders of an age that is past, still serve the city's faithful today. As seen from the Gulf of Panama, the latest in architecture dominates the city's skyline. An up-to-date airport accommodates the sleek jet aircraft of many nations. Modern recreational facilities are plentiful. Panama is unexcelled for either salt or freshwater fishing. The long famous Panama Canal still stands as one of man's great feats of engineering. Yet for all its modern aspect, Panama retains the flavor of its past heritage, the colorful folk dances of the Panamanian people. All around this center of commerce and culture lies the primitive jungle, setting for the United States Army's tropic test operations, the Big Green Laboratory. Since 1962, the United States Army Tropic Test Center has used the Canal Zone's wide variety of natural environments to test men, materials, and equipment in the humid tropics. The crucial need for such testing is clear when you remember that some 20% of the world's land area has a hot and humid climate. The Panama Canal Zone is uniquely suited for tropic testing. In its relatively small area of 500 square miles, nearly every feature of the humid tropics can be found, and 3 different types of tropical environment exist. For example, the Atlantic coast of the isthmus is covered with wet evergreen forest. Here, from 100 to 200 inches of rain falls each year. Even during the driest period, February and March, it rains on about 15 days of each month. Temperatures range from the mid-80s in daytime to the mid-70s at night. The relative humidity hovers at 100% almost every night and often during the day. These are the same conditions that military equipment and operations would face in southern Burma, Malaya, parts of Central and South America, and parts of Africa. In general, it is a region teeming with all kinds of plant and animal life. On the Pacific coast, there's a second major type of tropic environment, semi-deciduous jungle. From 60 to 100 inches of rain falls each year. and there are distinct wet and dry seasons. In February and March, the driest period, less than 1 inch of rain falls per month. The ground bakes hard and often cracks open. The grass turns brown and some trees shed their leaves. All conditions found in much of Vietnam, Laos, Cambodia, parts of Central and South America, and parts of Africa. During the wet months, however, there's ample precipitation to qualify this area as a humid tropic environment. Southwest of the zone at the Rio Hato Military Reservation, broad reaches of tropical savanna or grassland provide a third major environment, typical of the humid tropics. Rainfall measures only 40 to 50 inches a year. The dry season is longer, and daily temperature and humidity variations are greater, as in the drier sections of central Thailand, parts of Central and South America, and parts of Africa. Within these 3 major types of environment, there is a wide variety of terrain, vegetation, soils, and moisture conditions, useful in testing equipment and materials. For example, there are sandy beaches, mud flats, coral reefs, sea cliffs, hills, steep stream banks, mountains, mangrove swamps, fern swamps, and several types of palm swamp. For mobility tests, there's an ample variety of soil types. Water barriers include the Chagres River, plus many smaller streams, and the Big Gatun Lake. So much for the Big Green Laboratory's natural resources for tropic testing. Now let's take a look at how these resources are put to use. The Army Tropic Test Center at Fort Clayton in the Canal Zone is one element of the Test and Evaluation Command, Army Materiel Command. As part of TECOM, the center's mission is to plan and carry out tropic environmental phases of engineering tests, service tests, evaluations, check tests, and confirmatory tests. The center also does research in support of its own testing mission and coordinates and supports research and development test projects of the Army, Navy, Air Force, and friendly nations. The center's permanent staff includes more than 20 military and civilian specialists in such fields as electrical, mechanical, aeronautical, chemical, and human engineering, as well as in geography, microbiology, meteorology, and soil sciences. The center also administers and supplies a locally based Army meteorological team. The team in turn supplies meteorological data for support of the center's projects. Administrative and logistical support is also given to the Air Force Systems Command Scientific and Technical Liaison Office, which arranges for Air Force support of test center projects. The headquarters building of the Tropic Test Center also houses its soils laboratory. Soils are tested at various locations in the field and samples taken for detailed laboratory study. The particular test being conducted here is to determine penetrability. Other characteristics of interest to the center's scientists include moisture content, stratifications, consistence, texture, color, acidity, alkalinity, compressibility, strength, plasticity, and remolding properties. The soils are grouped according to a scientific system by which hundreds of thousands of soil types from all over the world are classified into 50 major groups, and within these, into many more orders and suborders. Such classification makes possible a scientific comparison of soils, which is of great value to both military and civilian research worldwide. In the laboratory, samples are analyzed for both chemical and microbial content. Special attention is paid to those properties which affect the corrosion of material and the evaluation of vehicular trafficability. As part of all tests, behavioral scientists consider the human element. How well does man match machine in the tropical environment? Nearby, Tropic Test Center troops are quartered in barracks typical of tropical Fort Clayton. A few miles away, adjacent to the Miraflores locks, are facilities for chemical, microbiological, and botanical work in support of the center's research effort. Inside this building is one of the world's most complete collections of Panamanian plants. Thousands of plants from the zone's test courses and research plots have been identified. Many of these plants serve as hosts for microorganisms which speed the deterioration of material. To study these microorganisms and those found on surfaces and in the tropical atmosphere, to determine their role in deterioration, this is the laboratory's primary job. Much new understanding of the deterioration process is being gained by center scientists, and this too benefits civilian research efforts as well as military. Support headquarters are located at the Las Cruces logistics area, which also accommodates munitions test grids. Also located here is the center's motor pool. There are open storage sheds for deterioration testing, also a small photographic lab and supply rooms. About half of the center's projects are conducted at Fort Sherman on the Atlantic side of the isthmus. In this building, the center operates a field office. Inside, air-conditioned space is available for visiting test teams to use as field laboratories or offices. Billeting space is also available. At material exposure sites in each of the various tropical environments, hundreds of samples of material are tested. For instance, various plastics, paints, and other preservatives of kinds used for both the military and civilian community. At this breakwater site, materials are exposed to a heavily salt-laden atmosphere. Test items at all sites are regularly inspected and the results recorded. Civilian producers of the items tested benefit from these findings, and the resulting product improvements benefit both military and civilian users. This site provides an open country inland environment. Periodic comparisons are made of the effect of exposure on various materials in the differing environments. Four main vehicle mobility courses are in use, 2 on each side of the isthmus. These courses afford a variety of terrain types, physiography, soil characteristics, and vegetation, as well as such features as abandoned gravel and dirt roads, grassland, jungle, streams, lakes, and rivers. At a 14-acre chemical grid area, such munitions as smoke, white phosphorus, and other types of hand grenades are tested. As in all tests, results are carefully recorded for detailed analysis. In the Cerro Tigre area, environmental exposure tests of chemical material are conducted. Also tested in this area are such items as chemical agent detection kits, protective clothing, and protective masks. At another location, the center operates a small chemical biological laboratory, primarily in support of chemical deterioration tests. As part of a long-range environmental data-based program, several 150-foot towers are being set up in each of the tropical environments. The objective is to compile year-round environmental data at various heights, from ground level to above the treetops. This white filter, blackened by particles from the atmosphere, has been exposed for only 1 week. The particles were collected by high-volume samplers as a part of studies on atmospheric contamination. Bubblers collect chemicals from the atmosphere at various levels of the tower. An air sampling device is used to draw off microorganisms. In general, the environmental data-based program calls for quantitative analysis of the microbial, chemical, and particle content of the tropical atmosphere to determine the influence of region, season, and height above ground level. Laboratory analysis of airborne contaminants are throwing new light on the nature of the deterioration processes which so violently attack materials in hot and humid climates. Also, as part of the data-based program, facts on soil, vegetation, animal life, and microorganisms will be recorded for a period of years. Thus, testing agencies will eventually be provided with a body of knowledge on tropical environments far more extensive than ever before. Here are some typical examples of tropical deterioration suffered by plastic, glass, cloth, rubber, metal, and wood. To combat such destructive effects, the Tropic Test Center has conducted or taken part in a wide variety of projects. Concepts, ideas, and theories, as well as materials and hardware, have been rigorously investigated to determine the effect of the humid tropics on the soldier's ability to live, to move, to communicate, and to shoot. For example, how well can a soldier hear the enemy in the dense jungle? What sound frequencies carry best through thick vegetation? How well can the soldier pinpoint the source of such military-type noises as troops marching, truck convoys, or undergrowth being cleared? Just how good are such ideas as soft landing devices? beacon lights to guide paratroops to assembly areas, or glide angle indicator lights to assist in safe night landings by aircraft. How adequate are certain items of equipment? For example, jungle boots, collapsible canteens, plastic water containers, tactical radios, protective masks and clothing, armored vests, hand tools, field rations, and shipping containers. What is the effect of tropic humidity on Army firepower? On small rockets or large guided missiles? And how well will the Army's newest weapons survive the tropic environment? For example, the red eye. The tow. The Sheridan-Shillelagh system. The chaparral, and the lance. These have been highlights of the work of the Army's Tropic Test Center. The center is relatively young in years, but it is dedicated to a time-honored tradition that the American fighting man deserves only the best. Keeping this always in mind, the Tropic Test Center works unceasingly to provide a kind of soldier's warranty to assure his ability to live, to move, to communicate, and to fight in any of the world's humid tropical environments. All this is a vital part, but only a part, of the vast work directed from the headquarters of the Test and Evaluation Command at Aberdeen Proving Ground, Maryland. Since 1962, at more than a dozen TCOM test centers, virtually every item used by the American soldier has been evaluated in every possible climate and environment and in every phase of development. Engineering tests. Can a vehicle take the punishment that combat terrain may give it? Is its water capability up to the standard set? Can it meet the needs of the soldiers who will have to depend on it, where dependability is often literally a matter of life or death? The answers are found in advance. Or how about a multi-unit design which is intended to function as a rapid assembly assault bridge when the units are linked together, and also serve as individual power ferries for vehicles and armor if the need arises? Will the concept really save hours of precious time at a vital water crossing? TCOM experts check it out. Will a new design for radio communications within the rifle squad do its job in actual use in the field? Intensive troop testing by TCOM will reveal the answer before any combat unit is asked to depend on it. Weapon systems which today stand guard over key installations in the combat theater were first tested and evaluated in depth by TCOM. Weaknesses searched out, strong points revealed and reinforced. The ability of a new oven design to produce hot biscuits for hungry troops in the field, or of gloves to prevent frostbite, or of field boots to resist rot, or of the fabric of a field uniform to stand up to abrasion, or of rain garments to keep a soldier dry. These things and thousands more must concern the people of the Army's Test and Evaluation Command. Because these thousands of items are destined to become part of the vast catalog of equipment, supplies, arms, and ammunition on which the effectiveness of the United States Army directly depends, each single item, every last component of every one of the tools of the soldier's trade must be as efficient, durable, and reliable as intensive testing and evaluation can make it before it is delivered to the combat zone. When weapons and ammunition reach this point, the time for testing is over. TCOM makes sure that testing has been done right. Here, the time for evaluating the effect of a dusty environment is past. The ability of a vehicle to overcome a terrain obstacle must already be proven before it faces that obstacle within artillery range of enemy forces. In cloud-shrouded mountains and in the dripping jungles below, the American soldier has a job to do. No part of it is easy or comfortable or safe. He must be able to have perfect confidence in his equipment, his weapons, the modern means of transport that makes him the most mobile, hardest-hitting fighting man in history. The fact is, the American soldier has that confidence, and it is well-founded, thanks to the professional skill and dedication of test and evaluation experts half a world away. The people of the United States Army's Test and Evaluation Command.